Welcome to AI Frontiers, where we explore cutting-edge research shaping our technological future. Today we're examining medical intelligence and multi-agent breakthroughs from December 6, 2025. We'll dive into 17 groundbreaking papers from the computer science artificial intelligence domain that are transforming medicine, finance, education, and beyond, as AI evolves from simple pattern recognition to genuine reasoning and collaboration. Picture this. While you're sleeping tonight, artificial intelligence systems around the world will save approximately 6 lives from brain cancer, prevent millions of dollars in financial fraud, and debug themselves to become more reliable, all without human intervention. This isn't science fiction. This is December 2025, and the AI revolution is happening in ways that would have seemed impossible just a few years ago. The 17 papers we're analyzing today aren't just academic exercises. They're blueprints for technologies that will transform our world in the coming years. These research breakthroughs reveal how AI is evolving from pattern recognition to genuine reasoning, collaboration, and self-improvement. By the end of this episode, you'll understand the cutting-edge developments reshaping medicine, finance, and education through artificial intelligence. The field of computer science artificial intelligence, or CSAI as researchers call it, is like a vast digital ecosystem where different species of algorithms evolve, compete, and sometimes cooperate. Think of it as a technological rainforest where neural networks swing through data like digital primates, while reinforcement learning agents hunt for optimal solutions like electronic predators, and knowledge graphs form the underlying root system connecting everything together. This ecosystem has been growing exponentially, branching into specialized niches that mirror the complexity of natural evolution, where breakthroughs in one area often trigger cascading advances in others. Our first major theme is the rise of multi-agent systems and collaborative intelligence. Krishna Arun and his team created what's essentially a team of AI specialists for treating glioblastoma, the deadliest form of brain cancer. Their system employs 4 specialized classification models for diagnosis and 3 generative models for treatment planning, each contributing unique expertise while maintaining constant communication about the patient's condition. Meanwhile, Ming-Ma's Dover framework takes this further, creating AI systems that can actually debug each other through targeted interventions, like having a team of digital mechanics who can identify and fix problems in real time. This jazz ensemble approach achieves breakthrough performance by allowing different algorithms to play off each other's strengths. The second major theme is reinforcement learning's evolution, from simple reward-seeking to sophisticated adaptive systems that understand context and constraints. Tinuli's Doji framework exemplifies this advancement through a dual decoupling approach that separates learning into 2 phases: a thinker that focuses on understanding problem context, and a solver that handles actual problem solving. This is like the difference between memorizing chess moves and truly understanding chess strategy. The thinker prevents the system from exploiting superficial patterns to achieve high rewards without genuine understanding, a problem that has plagued AI systems for years. This approach ensures that AI systems develop genuine comprehension rather than just pattern matching. Medical AI represents our third major theme, where the stakes couldn't be higher since we're dealing with life and death situations. Mohan Haidari's Echo Copilot system demonstrates how AI can assist doctors with complex medical interpretation tasks, specifically analyzing echocardiograms with superhuman precision. What sets these medical AI systems apart isn't just their accuracy, it's their ability to explain their reasoning in terms that doctors can understand and verify. Picture a brilliant medical student who never gets tired, never forgets a detail, and can process thousands of similar cases in seconds to inform each diagnosis. These systems must always show their work and remain humble about the limits of their knowledge. Now let's examine the key findings that emerged from this research. Krishna Arun's team achieved a staggering 22.28 times reduction in computing costs for their glioblastoma treatment system compared to traditional approaches. To put this in perspective, imagine if your smartphone suddenly became 22 times more powerful while using the same amount of battery. This efficiency gain came from intelligent system design that mirrors how human experts actually work, using a cascade of increasingly specialized models. The system's projected 0.9% improvement in survival rates translates to approximately 2,250 lives saved annually when applied to the global patient population. Additionally, the 113-hour reduction in tumor progression inference time enables real-time, personalized cancer treatment that adapts to each patient's unique situation. Today's featured research is utilizing multi-agent reinforcement learning with encoder-decoder architecture agents to identify optimal resection location in glioblastoma multiforme patients by Krishna Arun and colleagues. This work represents the first end-to-end artificial intelligence solution for treating glioblastoma multiforme, the most aggressive and deadly form of brain cancer. To understand why this matters, consider that glioblastoma has a 5-year survival rate of just 5.1%, making it one of medicine's most formidable opponents. Patients typically have a life expectancy measured in months, not years, where every day of delay can mean the difference between life and death. The system employs 4 diagnosis models, working in a specialized relay sequence, followed by 3 treatment models, handling surgery, radiation, and chemotherapy planning. The technical innovation behind this glioblastoma system is remarkable in its sophistication. The diagnosis phase starts with convolutional neural networks that identify potential tumor regions in brain scans, trained on thousands of brain images to spot subtle patterns that might escape experienced radiologists. Support vector machines then provide precise classification refinement. For treatment planning, diffusion models predict surgical outcomes by creating detailed simulations of how different surgical approaches might affect brain function and survival prospects. Spatiotemporal vision transformers simulate radiation treatment progression over time, essentially creating detailed movies of how radiation will affect the tumor and surrounding tissue over weeks and months. Finally, proximal policy optimization iteratively refines treatment recommendations based on predicted survival outcomes. The real-world impact extends far beyond the impressive numbers. The system achieved a 2.9% improvement in tumor boundary identification through DICE scores, which translates directly to more accurate surgical planning and better patient outcomes. The 113-hour reduction in analysis time makes real-time treatment planning possible, allowing doctors to adjust strategies as they're being implemented based on patient response. However, important limitations exist. The system relies primarily on MRI data and might miss clinical factors like overall health status or genetic factors. Clinical validation across diverse patient populations remains needed, and integrating such complex systems into existing hospital workflows presents significant practical challenges. Looking toward the future, this research points toward exciting directions that could reshape how we interact with artificial intelligence. The most promising development is the emergence of truly collaborative AI ecosystems, where multiple specialized systems work together seamlessly. Imagine a future where your personal AI assistant collaborates with your doctor's diagnostic AI, your car's autonomous driving system, and your home's smart management system to create a comprehensive support network. These systems wouldn't just share data, they'd engage in sophisticated reasoning about how to best serve your interests while respecting privacy and autonomy. Self-improving AI systems that can identify their own limitations and actively work to overcome them represent another frontier, potentially democratizing access to expert-level analysis globally. In conclusion, the 17 papers we've examined today reveal AI's evolution toward genuine collaboration and reasoning capabilities. Medical breakthroughs are already saving thousands of lives annually, while efficiency gains are making previously impossible applications feasible. The 22.28 times reduction in computing costs, combined with systems that can debug themselves and work collaboratively, represents a fundamental shift in how we approach complex problems. However, transparency challenges in academic AI usage require addressing to maintain scientific integrity. The future promises truly collaborative artificial minds that can work together to solve humanity's most pressing challenges. This analysis was created through synthesis using GPT and CLAUDE-SONNET-4-202505114 models with TTS synthesis powered by DeepGram technology and image generation through OpenAI systems. All synthesized content underwent human expert review to ensure accuracy and clarity. We acknowledge that some oversights may exist and full references are provided for verification. This comprehensive approach ensures that complex AI research is made accessible while maintaining technical accuracy and scientific rigor. Subscribe to AI Frontiers for cutting-edge AI research analysis and weekly deep dives into breakthrough papers. Join thousands exploring the AI revolution together as we guide you through the technologies shaping our future. Never miss the developments that matter most in artificial intelligence and computer science. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive-preprint-server.org, content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive-preprint-server.org.